Hey everybody, this video is meant to help you out with your cool down for lesson 5. So I've made a similar example here. It says use the first 5 terms of sequence named H to define the sequence recursively. So we learned about the recursive definition today. So we're going to define the sequence recursively using function notation. Our sequence H starts with 3.5, goes to 10.5, and so on. All right, so looking at this sequence, I got to think about what rule is happening here. Well, I think multiplication, I can't really think of something off the top of my head right away that would be 3.5 times something to be 10.5. But if it's multiplication, I could try something like 10.5, the next term, and divide it by the previous term. So 10.5 divided by 3.5. And I could try to see if I have this common constant growth factor here. So 10.5 divided by 3.5, if you did that with a calculator, you'd get 3. Okay, so that means that if I multiply 3.5 times 3, it gets me to 10.5. But let's check to see if that continues. If I multiply 10.5 times 3, does that equal 17.5? You tried it out with a calculator? No, that does not work. We multiply 10.5 by 3, that's going to give us like 31.5 or something. So no, that didn't work. So I know now that I'm not multiplying. That is not my growth factor. It's not going to be a geometric sequence. It might be arithmetic. That means there might be a common difference. To check for a common difference, I could take the next term and subtract the previous term. So I could be like, hey, 10.5 and subtract 3.5 minus 3.5. That gives me 7. All right, so this is my potential common difference. I could check that, see if I'm adding by 7, because I got a positive 7 here, plus 7. Hey, this sequence is increasing by 7 there. Does it work again? 10.5 plus 7. Yep, that's true. 10.5 plus 7 is 17.5, and so on. 17.5 plus 7 gives me 24.5. We can keep checking, but we can see now that we're just adding 7 every time. So our rule, if we wanted to write it, is to get to the next term, add 7 to the previous term. That's our rule for this sequence. Keep that in mind as we try to create this recursive definition here. Sorry, motorcycles driving by as always. All right, so we need our recursive definition. First thing we must always include in our recursive definition is the initial value. So I look at my sequence, and I see my initial value. The first term is 3.5. So we would say that h is 1, so h of 1, it's the first term of sequence h, is equal to 3.5, comma, well, to get to the next term, that's our h of n, it will be equal to the previous term, h of n minus 1, plus 7, because we're adding 7 to the previous term. So just to remind ourselves, this right here, this is our initial value. Do that in blue. So we always state our initial. That's the first thing we include in our recursive definition. Next up, right here, is h of n. Well, that's just the next term. So that's saying to get to the next term, what we're looking for h of n. All right, and then we can see this right here, h of n minus 1. Well, that's just our previous term. Change the color on this to yellow. H of n minus 1 is the previous term. And then we have this plus 7. That's just our common difference in this case because it's an arithmetic sequence. We're adding by 7. This is our common difference. If it was multiplying by 7, then we wouldn't call it a common difference. That would be our growth factor. So again, this matches our rule. We start with 3.5. That's our initial value. To get to the next term, we're going to take the previous term and add 7. All right, hopefully this helps you with your cool down. Here's might not be the same idea. We might not be adding by 7, but hopefully this gives us an idea. All right, see you next time.